This is homework help for worksheet 7. And in this video, I'm going to go over numbers 2, 5, and 11. Okay, so I'm going to start off with number 2. The directions say convert to descriptive form, sketch and identify the following, which is the vertex, the axis of symmetry, focus, directrix, and focal chord endpoints. Okay, so this is very, very similar to worksheet 5. We want to rewrite this in descriptive form. The form is currently in focal chord width form, okay? And so to get this in descriptive form, we need the fraction in the front, or we need to see our stretch value. So to do that, we divide both sides by 4, and I get 1/4 times the quantity y plus 2 squared is equal to x plus 1. And now you can see your hk. Your h comes from the term next to the x, your k comes from the term next to the y, and it's always opposite, okay? So our hk is 1, -1, comma, -2. Okay, and then we can answer these other questions, but sketching the graph helps us to find those a little more easily. Let me zoom out a tiny bit here. So to graph this function, we plot the vertex first, so -1, -2. And then to find the focus, we are going to move the c value. We also need to figure out what the direction is. And so when we look here, I can see that I have a y squared term, and if you look on the board, that y squareds are left and right parabolas, or horizontal parabolas. Because this is a positive y squared term, our parabola is going to be like a C curve, going to the right, or opening to the right. And the focus is always on the inside. To find this distance here, c, we take our fraction 1/4, and we set it equal to 1/4c, and cross multiply. So 1 times 4c is 4c, 1 times 4 is 4, and when you divide both sides by 4, you get a c value of 1. So that means our focus is 1 to the right of the vertex, and we're going to label that coordinate, that's 0, -2. And then the directrix is the vertical line that is equal distance from the vertex and the focus. And so if this is right 1, then the directrix is left 1, and it's a vertical line. The directrix is an equation of a line, so it's always x equals for a vertical, and so that's x equals -2. Okay, and then you can find your focal chord endpoints by going to your focus, and you're going to go up and down to c. Our c value is 1, so we're going to go up 2 and down 2. Okay, and so those coordinates are 0, 0 for the one on the top, and the one below is -1, -2, 3, 4, 0, -4. Okay, and then you can create your parabola by connecting the vertex to each of the focal chord endpoints and a C-type curve. Now this line of symmetry, also known as the axis of symmetry, is the line that cuts the parabola exactly in half. It's invisible. It goes through the vertex and through the focus. Now if I had drawn this perfectly symmetrical, I should see a mirror image on either side of that horizontal line. Again, like with a directrix, it's a line, an equation is needed when we write that. And so I look, you can see that it's horizontal, so that's a y equals equation. And that y-intercept value is at -2, so it is a y equals -2. You may be asked questions like, how many x-intercepts does a graph like this have? And I can see here that it crosses the x-axis once. You may also be asked on the test, how many y-intercepts does the parabola have? And I can see here that it crosses the y-intercept twice. You don't count the focus as a y-intercept because it's not actually a visible part of the parabola. Number 5 is very, very similar, but in this one we are going to look at those intercepts, okay? So the first thing it says is to convert to descriptive form. This is focal width form, kinda. I need my x's and y's on opposite sides, so I'm going to subtract this onto the other side, and I get x minus 5 squared is equal to -3 times y minus 2.
And now this is focal width, so I need to divide by -3 on both sides to isolate or get my stretch value next to my squared term. So it's going to be -1/3 times x minus 5 squared is equal to y minus 2. The hk comes from the values next to the x and the y. So it's opposite of -5 is 5. Opposite of -2 is 2. So my vertex is at 5, 2. 1, 2, 3, 4, 5, and 2. This time when I determine my direction, I can see that I have an x squared, which is going to give me a vertical graph. And the negative means that it's going to be opening downwards. Remember, the focus is always inside of the parabola, inside the U-curve. So to find that point, I need to find my c value, and I take my fraction 1/3. I don't need to worry about the negative because I already know it's going downward. I set this equal to 1/4c. When I cross multiply, I'll get 4c equals 3. And when I divide by 4, I get a c value of 0.75. So I'm going to go down 0.75. And I'm going to go up 0.75. I'm not asked to give those values, so I don't need to give the equations this time. But I do need to get those focal chord endpoints just to get my nice sketch here. And so my focal chord endpoints are found by going left and right from the focus, 2c, and 2c would be 0.75 plus 0.75, which is 1.5. So I'm going to go left and right, 1.5. And I'm going to draw that upside down U-curve. The line of symmetry again is the line that goes through the focus and the vertex. This time it's vertical, so it's going to be 1, 2, 3, 4, 5, x equals +5. And now I need to calculate the number of x and y intercepts that I have. I look at my graph and I can see that my parabola crosses the x-axis twice. And it doesn't look like it crosses the y-axis because I don't have a point on it, but if I drew this out further, I could see that eventually the parabola would cross the y-axis one time. Okay, and then look at the homework. I take it back. I want to go over number 12 on this worksheet now instead of number 11. I think number 12 is just a little bit harder, and I want to make sure that I address that problem. So, for number 12, again, we are asked to convert to descriptive form, but this time it's a circle because we have an x squared and a y squared. So descriptive form of a circle will look like this: x minus h squared plus y minus k squared equals r squared. Okay? So in order to rewrite our polynomial in this form, I need to put my x's next to each other. And my y's next to each other. And then this 5 is not in a good spot. Okay, it's an extra number that's going to affect the radius, but I want it out of the way so that I can complete the square. So I'm going to move the 5 to the other side, and I end up with x squared plus 8x, and I'm going to leave a space, plus y squared minus 2y, and again I'm going to leave another space, equals 0 minus -5 is -5. But I need to add 2 spaces on the right for the completing the square. So to complete the square here, I take my 8 and I divide it in half. 8 divided by 2 is 4. And then I square the 4, and 4 squared is 16. So that gives me this value here. I have to add it to the other side. I'm going to do the same thing with my y's. I take the middle term here, -2. -2 divided by 2 is -1. And when you square the -1, you get a 1. And that's what we're going to add here and here. Okay. Now that I have this trinomial, I can factor it. And if you remember the shortcut, it's always x plus this number here. So x plus 4 squared plus, and then I'm going to factor this one. And I can factor it using box and diamond if I want to, but it comes from this number here. So it's going to be y, not x, minus 1. Okay. And then on the right-hand side, I combine like terms and add. So negative 5 plus 16 is 11, and 11 plus 1 is 12. So the center comes from the hk. Remember the h is the one next to the x, so that's going to be 4, but then it's opposite, so it's negative 4. And then the k comes from the value next to the y, and it's opposite, so this is minus 1, this will be a positive 1 here. The radius is not 12. You need to take the square root of 12 to get your radius, and so remember this is r squared here. So r squared equals 12. We're going to square root. The radius is always positive, so I don't need plus or minus or absolute value. But then I need to break down the 12. 12 is 4 times 3, and the square root of 4 is 2. So you're going to get 2 square root 3 for your radius. Now we need to sketch it so that we can answer the other questions. Okay? So we're going to plot our center. That's negative 4, 1, 1, 2, 3, 4, and a 1. And then our radius is 2 root 3, which is kind of tricky for some of you to graph. So if you go back to the 12, square root of 12 is between square root of 9 and square root of 16. Square root of 9 is 3, and square root of 16 is 4, so the square root of 12 is somewhere between 3 and 4. So you could use like 3.5 if you want. So I'm going to go right 1, 2, 3, and a little bit. I'm going to go up 1, 2, 3, and a little bit. Left 1, 2, 3, and a little bit. Down 1, 2, 3, and a little bit. And then you can make your circle. Now when you calculate your x-intercepts, I can see that the graph crosses once and twice. So I'm going to have 2 x-intercepts. But for my y-intercept, it looks like my circle is touching right here, but I have to remember that radius was between 3 and 4. If it was 4, it would be on the axis, but it's less than 4. So it's actually just left to the axis, and so I have no y-intercepts, or 0 y-intercepts. Okay? If you need additional help, please attend Math Lab this week with Mr. Dittman in room 308, Tuesdays, Wednesdays, and Thursdays from 2:45 to 4:45.